TIFAC has initiated the TIFAC Tech Talk recently by inviting eminent experts to talk about the latest technology and science innovations shaping our lives. We are happy to have Dr. VijayRaghavan, Principal Scientific Advisor to Government of India, to give his first Tech Talk on TIFAC on Reboot, Reinvent, and Resilience Road Ahead. He would be joining us online today. Professor VijayRaghavan, he's a fellow of the Royal Society and an emerite professor and former director of National Center for Biological Sciences. He has served as a secretary in the Department of Biotechnology and is presently the principal scientific advisor to Government of India. Dr. VijayRaghavan, please.
Thank you very much. It is a great pleasure and honor to be here today to deliver the lecture, and I apologize I could not be there in person. Dr. V.K. Saraswat, Professor Ashutosh Sharma, Executive Director of TIFAC, Dr. Srivastav, Dr. Vijay Chauthewale, and distinguished colleagues. First of all, I'm greatly honored to be asked to give this talk today, and I apologize for not being able to come there in person. But I will do my best, and I'd like to congratulate TIFAC on its foundation day. The topic of my talk is about reboot, reinvent, and resilience. And the question really is, what is the purpose of having to reboot today? And that has been exemplified by the pandemic, and starting in the year 2021 and going 2020 and going on to this year. If we were to have this meeting in 2019 end, we would have taken a very different view of what we need to do in the context of science and technology for societal and economic development. We would have charted out the situation in the globe. We would have said that the West is at a particular situation, the East is at another situation, China is doing something, Japan is doing something else, Korea is doing something else, and this is what we need to do. And we would have argued about how we need to reformat a variety of structures to catch up. But 2020 turned that all upside down. And in turning it upside down, it both has asked us to rethink the complexities of what we need to do, but perhaps also opened some opportunities on how to do that. Fundamentally, the critical point I would like to make are three. One, the paradigm which we have used, starting from the first industrial revolution, going up to the Industrial Revolution 4, is a stepwise, essentially linear development of a certain philosophy with a sharp slope, and that has changed the world enormously. So that is something to be kept in mind. The second point I'd like to make is, however, three other things have happened, and they will be the points which I shall discuss. One is we have changed the world because of greenhouse gases through climate change. Secondly, we have changed our biodiversity. And thirdly, we have invented technologies such as artificial intelligence and so on, which have changed the way we function. So this is the second component. And the third component is, how do we go ahead from this situation? Given all of this has happened, what do we do? So let me briefly summarize where we are. Now, what happened at the start of the Industrial Revolution was something quite dramatic. Before that, we had agricultural communities, and humans had moved to cultivating and domesticating livestock and plants on scale. But there was a fundamental challenge which humans faced in doing that. There were limits to growth because there were limits to what the soil could give. Wherever you cultivated soil, you had two kinds of issues you had to deal with. You had to clear forest land or other land for soil, but you also very rapidly depleted the soil of resources. To bring back resources to the soil, what humans did was to put into the soil back again nitrogenous fertilizers. The first kind of nitrogenous fertilizers on scale, as distinct from manure and so on. The first kinds of nitrogenous fertilizers on industrial scale were bird droppings or guano. So as agricultural economies grew, they went to, precipices near the sea or other areas in China and South America and collected bird droppings rich in phosphate and brought them and used them as fertilizers. This very rapidly ran out, of course. The next thing people did was went to nitrite mines, and this was largely in the West where, industrial scale agriculture was developing. The next thing they did was to go to nitrite mines in South America and China, and they too started running out. The third thing, therefore, they did was to try and see whether science and technology could invent a way whereby you could make fertilizers without being limited by these kinds of mines. And that was done and doable by the Haber-Bosch process, which captured nitrogen from the atmosphere and converted and made it into ammonia, nitrogen and hydrogen. Now, the result of the Haber-Bosch process is the growth of agriculture on scale, and today half the nitrogen in our bodies comes from the Haber-Bosch process. So you can imagine what dramatic change this has had on humanity. There have been other consequences of the Haber-Bosch process also. In other words, humanity was no longer limited by food supply being a problem in one way or the other. Of course, there are other kinds of changes which took place because of our understanding of agriculture, of animals, and so on and so forth, leading to multiple revolutions where food was not limited. In a similar manner, just as food was not limiting, the industrial revolutions got ores of various kinds, developed technologies to use them, got resources for energy, petroleum, developed technologies to use them, and then neither minerals nor energy was limiting for the rich. In other words, you had a spiraling growth of countries which basically ruthlessly, for what they thought was public good or their good, exploited resources of various kinds and used science and technology to make sure that those resources were not limited. The third component which these countries did was to use markets, either through colonization at early stage or by commerce later on. So this resulted in thermodynamically closed systems where you could have very low entropy and great organization at the expense of the ecosystem outside, where entropy increased, chaos increased, poverty increased, and markets were used. And the result of these kind of ways by which we created these closed systems, where these closed systems looked idyllic, but the entire planet became a problem. Now, this poses a fundamental philosophical problem in that, is it possible to develop in a sustainable manner for the whole world as exposed to a part of the world? You can have the Nordic countries, for example, having a high quality of living and sustainable development, but they have oil to export, they have other kinds of exports to do, and therefore this concept of having a closed system which is well ordered, but the outside chaotic, is something which is natural in terms of thermodynamics, in terms of the energy required to get order. But today's challenge is a different one. Can you have global sustainable development without exploiting your natural resources, without exploiting your people or other people, and yet have sustainable development? And this is the principal challenge which we face today. Now, what we have done because of our earlier roots of industrial revolution is we have created major issues on climate change and on biodiversity loss. And I won't get into that, but that really is a consequence of having inexorable development of a certain model. Now, if countries such as India need to have massive development and yet do that in a sustainable manner, we have a big challenge. Now, there are two aspects to this which we must keep in mind, and the question is how we can deal with those aspects. One is a very general one about how does one have the tools for sustainable development coming into countries like India. While major powers in the world, the Western powers, other countries, say that one must have, a lowering of emission of greenhouse gases, consideration of lowering fossil fuels, have renewable energy and so on. That is good, and India is doing an extraordinary job there. In addition, India has made demands, and which we must keep pushing more and more, that this must be accompanied by tech transfer on scale. If you want large countries like India with extraordinary science and technology base available to have sustainable development on scale in a manner and reach standards of living similar to that in the West without damaging the environment, tech transfer is a key requirement, and for the safety of the planet, that must be done. So this is something we should constantly articulate and get done in every area we work on. Otherwise, it will be just platitudes to say, don't do this, don't do that, and so on. But talking about all these kinds of platitudes from a position of having already done everything and raised your standard of living and preventing the aspirations of others. So how to balance this is a big challenge. Now, let me take this point from the aspect of, how one can deal with these issues technologically, an intrinsic purpose. And that is, again, something very feasible, and I must credit our science agencies, the Department of Atomic Energy, Space, the DRDO, the DST, and DBT, CSIR, ICAR, and other agencies for taking on this challenge since the last several decades. And because of that, India is in an extraordinary position where its industry and its science institution can understand and develop any technology. The challenge we have is not in the development of technology per se, that can be done both indigenously and through collaboration, but in linking this to market on scale. Because one is already faced with a situation where global markets are of such high size that it becomes a big challenge for us to do something which can not only be technologically satisfactory, but have global markets. Now, one route to that, many people say, is of having certain kinds of non-tariff barriers and other kinds of standards regulation, which many countries have, so that we import less and we manufacture more. And that's, of course, a very important route, and we must have that more and more. Today, almost every kind of consumer item which we use comes because of these barriers not being clarified, these standards not being clarified, and there is a one-way street of huge imports, whereas countries to which we would like to export have, put in these kinds of barriers. So a balance of payments need to be adjusted, and this is really a commercial discussion for our Commerce Ministry to work with other agencies. From a scientific perspective, though, there is a big challenge. In many areas, such as semiconductors as a standing example, but this is true for biotech, for material science, for areas such as dealing with agriculture technologies, pharma technologies. In all this, we are fully capable of developing technologies and showing proof of concept, but scaling up is a big challenge, and we need to do that both technologically also. So it is inevitable, given that others are not sitting quiet, that these kinds of strategies for scaling up will have to fight against various competition, and it will scale up steadily and linearly. But there was an opportunity in certain areas for us to scale up exponentially. And this is a very important aspect which we should now grasp. Today's world has changed, and this is particularly true since the last year in terms of that opportunity. But for several years, the world has changed in that manufacturing is distributed and design is the core. In other words, whatever it is, whether it is subtractive manufacturing, additive manufacturing, manufacturing shoelaces or telescopes, all of this, design is a critical aspect. Design and prototyping can be done locally, and then the design, the intellectual property of it can be exported. India is doing a lot of this by our talented scientists and engineers working for global companies in here. But this kind of working could be anywhere on the planet. It doesn't have a rootedness and a connect to India. So we must break open entrepreneurship in design so that design companies anchored and linked to Indian academia flourish, and they can, make products for any kind, anywhere in the world. So we must move from, we've already moved from low-end call centers to intermediate range call centers, but we must now move, and those intermediate ones, for example, analyze data in medicine and geology and so on and export that. But we must now move to a much higher level where we actually make products, design them and export the designs so that we can compete in a new world in the fourth industrial revolution where manufacturing is taking place in a cyber-physical world close to the sites of big companies, and labor and manufacturing arbitrage is no longer very easy. So this new aspect needs to be thinking. Now the last point, as I said, I will make is about artificial intelligence and the handling of data. And this is a serious matter which we need to do by training on a large scale. With the onset of the analysis of data on scale, what has been true for many thousands of years, that is, people with knowledge have power, is amplified to a very great extent now. Companies with knowledge have global power disproportionately, and they will tell everyone from school children to farmers to pilots to where you want to eat about what you need to do and what is best for you. In other words, people on scale will be dumbed down and their decision making will be given to other people to tell them what they have to do. And those decisions may actually be useful. What does one do in such a situation, particularly in countries with a large population and a large young population? We cannot be dumbed down into becoming a world's largest service sector industry, and therefore, to deal with that, we must have education in mathematics, statistics, and computer science on scale, and get artificial intelligence-based decisions, machine learning-based decisions, which are a consequence of those kinds of learning, into our population in general, so that knowledge and power can be more distributed. It's easy to say this, it's very difficult to do, but this means that right now, when 90% of our resources in research go to places where 10% of our students go, and we need to amplify research into areas where schools and colleges, where 90% of our students go, are state universities and colleges. Unless we do that in an organized, structured manner very rapidly, we will lose out. But the advantage of studies in these kinds of areas is that the impact can come relatively fast because the impact is brought by younger people. The new National Research Foundation, which was announced in some detail in the budget this time, will hopefully be with us very soon, and a partnership with all of us here to make sure that education and training in research in general and science and technology in particular reaches large masses of our people is the only way we can compete in the world and look for a sustainable future for the planet. Thank you very much.